Hello, I am Ansh Joseph. I built FlowKit. It is a highly scalable solution for running AI pipelines. It basically distributes the workload between multiple worker nodes and it can give the result in real time. First of all, we start with our demo. Then I'm going to explain our architecture which I use for building this. Created the nodes. It is our start node. You can see I build a particular library which runs on our worker nodes. It basically helps to communicate with our services like our secret key manager and all that stuff. So first of all, we basically import the libraries, initiate the node, initiate the logger, and make a main function. Uh, the this library has a entry point function. Okay, so you have to make this main function, and it basically we gets the inputs, and you can see over here there is a current input JSON. Okay, so by giving inputs over here, you can also provide the input at the start node. So we currently not providing any inputs, so it's empty right now. So after that, the return is quite interesting. So return first, the argument is the nodes. So the nodes are the nodes which is connected to this node, and this is output of this node. It basically goes to the input of this nodes, and this is a message for debugging. After that, there is node one. You can see points to node one. So in node one, I basically import all the stuff, and I also import the OpenAI library and initiate this as usual. And I use this special expression to get the grok key from the secret key manager. And the process is quite same. I initiate the client and just put some random response over here and just returns this response at the output. And you can see the return key nodes were empty. Basically, it executes the graph in a breadwise manner. Okay, so it basically when it's empty, then the node queue was empty, then it basically shut down the process. So now save it and now execute the flow. Okay, so you can see the flow is executed right now. So the first node there is trace one, start and node one, and there is traces. So traces is basically managed by our trace server. It basically maintains all the inputs and outputs of the node for debugging purposes and also for the tracing purposes. So you can see our trace one node name start basically outputs node one output A and B with some value one and two and status done and it runs successfully. After that, there is flow ID and flow level and current sequence level. You can just use this for filtering and all that stuff. After that, the node one is executed. It is also executed successfully. It has inputs A and B, and it has some logs. And you can see our output. Output is tree, and LLM response to this. It also runs successfully, and there you go. And basically, you can make anything with this type of system. You can make multiple nodes. It's like parallel nodes and all that stuff. The parallel nodes have one problem, so I've solved it. You can basically make a tag like here, combine is equals to true. What does it does is like when the same nodes are in the queue, it basically combines its inputs and provide and run that node in a single instance. So it basically runs a parallel node and it can do self loops and all that stuff. So that's it for our demo. Let's go with the architecture. So this is the architecture which we are using for this system. So at the bottom we have NPUs. So NPUs are the worker nodes. You can see over here we have the NPU resource monitor. There is one NPU initiated right now, and if I want, I can initiate one more NPU. Just create one step, let the terminal initiate itself, and run main.py, and you can see the NPO is initiated. There you go. The new NPO is initiated right now. Okay, so it is quite easy to scale up and scale down. The next thing is our node runner. It basically schedules, monitor, manage the NPU and the node task, and also it resolves the secret key, basically this expression. So over here. Basically, it resolves this kind of expression and just get the secret key from the secret key manager. After that, we have this FlowKit control unit. It basically is the brain of our system. So what it does is mm, basically runs this flow, and then monitor its output. It communicate with the graph trace server, which basically just put all the inputs and outputs over there of each node, and it basically has all the it basically controls the block, and it's like it has some variables. I can basically show you what it basically contains. And it contains, actually it has FCBs. It's basically flow control block I inspired from operating system. So it is one of our test flows. So it basically contains the number of nodes. There is start node. Now you can see there is start node and there is node 1. There is current input and the current output. It basically contains the flow, and by using this kind of structure, we can basically pause, resume, or do any kind of stuff in our system. And it is also gives us power to recover from failure. If somehow our flow control unit, it's like flow kit control unit, shuts down. So it basically can recover from the database again. It is recoverable, and every node is atomic in nature, because it means it's like the node gonna execute or it's gonna not execute. The state gonna be saved in our secondary storage. And we have one more thing is like it is a secret manager. You can see over here with our secret manager, and I stored the key graph over here, and this is my API key which I used, and this is our UI. So basically the system is you can scale the system at any rate. It's like how much you want, because you can basically use a reverse proxy over here. It basically works on webhooks. So you can put a reverse proxy over here and run multiple node runners without any issue. And this flow control unit also can be kept behind a reverse proxy, because it basically communicates with the trace, and we can just put the flow the it's like the flow JSON, it's like the payload over here, the program payload over here, and it basically gonna execute anyhow, and it basically stores the graph trace over here, and you can basically get that trace in the UI. So basically the thing is that you can scale the system uh, theoretically without any limits. There is no single point of failure. You can just replicate the nodes, basically the replicates the server anyhow. So that's it for our architecture.